Okay, so in a right triangle, the hypotenuse squared is equal to the sum of the squares of the legs. So this is in words, a lot of words. This is our equation. In mathematics, we try to make things into equations once we have found a pattern. And the way that you've seen this equation, the hypotenuse squared is equal to leg squared plus leg squared. In middle school, you said a squared plus b squared is equal to c squared. I just rearranged this equation. Okay, where the leg of the triangle is the side, one of the sides that forms the right angle. So whenever you see the right angle here, this little box, then that means that we have a right triangle, and the two sides that form this 90-degree angle are called the legs. Opposite from the 90-degree angle is always the hypotenuse. Okay, so let's look at this example here. We have a leg that's 5 units, a second leg that's 10 units, and then we have this variable c. And the question is, are we missing a leg or the hypotenuse? Well, we have the 90-degree angle here, and opposite the 90-degree angle is the hypotenuse. And since that is where our variable is, that means that we are searching for the hypotenuse. Now let's substitute into our equation what we know. We know that we are looking for the hypotenuse. So c to the second power is going to be equal to leg squared, so 5 squared, plus the second leg squared, 10 squared. So 5 squared, that means 5 times 5, which is 25. 10 squared means 10 times 10, which is 100. Now we're going to have 125. Now remember that since we are not looking for c squared, we want to figure out the actual value of c, we're going to have to take the square root of both sides. And when we take the square root, we're going to end up with 125. Now, 125 is not a perfect square, so we're going to need to factor 125. And I know that because this number ends with a 5, I will be able to divide 125 by 5 and get a whole number. Okay, so my factors of 125, 1 and 125. Well, 1 is a perfect square, but it still leaves me with a factor of 125, so that's not very helpful. Now let's look at the other factor. When we divide 125 by 5, we get 25. So I can rewrite this equation. The square root of c squared is just c. And then take the square root of 25 times 5. Now, 25, is that a perfect square? Yes, it is. 5 times 5 gives us 25. So the square root of 25 is going to be 5. And then the square root of 5, that's not a perfect square, so we just leave it alone. So our final answer is that our hypotenuse in this particular case is 5 square root of 5. Okay, so this is how we go about solving a problem when we're solving for the hypotenuse. Now, how different is it to solve for one of the legs if one of these side lengths is missing? For that, let's look at the next exercise. Okay, so in this case, we have this right triangle whose hypotenuse is 16. One of the legs has a variable x, and the other leg has a value of 4 units. Since x is what we're looking for, and that side forms part of the 90-degree angle, that means that we are looking for the leg. So let's set up our equation. We know that hypotenuse is going to be 16. So we say 16 to the second power is equal to x squared plus 4 squared. Okay, so 16 squared is going to be 256. 4 squared is 16. Now we want to solve for x, so that means that in order to isolate x, we need to get rid of this positive 16, and we need to get rid of that square. Okay, to get rid of that positive 16, we need to subtract 16 on both sides. And that leaves us with 240 is equal to x squared. Okay, what is the inverse operation of squaring? We need to take the square root. Okay, so the square root of both sides is going to give me x on the right-hand side. And now we need to look for factors of 240. So let's think of a few factors. Again, 1 times 240, not very helpful. We can say 240 divided by 2, that's 120. But neither 2 nor 120 are perfect squares. You can say 240 divided by 4 would give you 60. So 4 times 60. 4 is a perfect square, but 60 is not. So perhaps 60 has another perfect square. So if we divide 60 by 4, we can get 15. So the factors that I ended up using were 16 times 15. And when you take the square root, and here I just rearranged this equation. Instead of saying square root of 16 times 15 is equal to x, I just rearranged it. And I separated the square root. So the square root of 16, that's a perfect square. So the square root of 16 is 4. And 15 does not have any other factors that are perfect squares, nor is it a perfect square. So our final answer is 4 square root of 15.